All right. So we're getting started here. Let's see. Probability intro. All right. So basically, three types of probability we're going to be learning today. Basic probability, right, which is just the basic probability that you guys are all knew from grade school, which essentially is just the outcomes over sample space. Then there's also, sorry, no, I don't have corona. Theoretical probability, and four is empirical probability. All right, so we're just gonna go through this worksheet, right, which is week 29, sheet 1. One of the greatest challenges is to try to quantify chance. But that's exactly what probability seeks to do. With probability, we attempt to assign a number to how likely an event. Remember, the key term here is event. Event comes up a lot in our definition of probability. How likely an event is to occur. Again, I'm looking at e-math learning, the worksheet I did assign. For those of you who are just coming here, just being curious, we're looking at an introduction to probability. This is part of an Algebra 2 Common Core curriculum. So terminology in probability is important. We introduce some basic terms. You have an experiment, right? Right? Basic probability terminology. You have an experiment, some process that occurs with well-defined outcomes. You have an outcome, a result from a single trial of an experiment, an event, a collection of one or more outcomes, right? A sample space, a collection of all of the outcomes of an experiment, right? So, hold on. Let me see something real fast, guys. Just check and see if everybody's here. Okay. So exercise 1 says an experiment is run whereby a spinner is spun around a circle with 5 equal sectors that have been marked off as shown. What is the experiment? Well, simply stated, the experiment here is the simple probability of determining which number, or the probability of a number landing on, the probability of the spinner landing on a certain number. Give one outcome of the experiment. So one outcome of the experiment could be 5, right? That's one outcome of the experiment. What is the probability of spinning the spinner and landing on an odd number? So between the numbers 1 through 5, we have three odd numbers. We have 1, we have 3, and we have 5. So we're looking at a probability of 3 over 5. If we're looking at C, it's 3 over 5. What is the event? Remember, the event is a collection of one or more outcomes. The event is landing on one of the numbers, one of the 5 sectors. Right? What outcomes fall into the event? Well, numbers. You achieve in numbers. The spinner landing on one of the numbers. Outcome is a result of a single trial. So the spinner landing on one of the numbers. All right. So then it goes on to say, the answer from C helps us to define the basic formula that dictates all probability calculations. The basic definition of probability: the probability of an event E occurring is given by the ratio PE, that's the probability of the event, over NE, which is the number of outcomes that fall into the event, where and NS is the number of outcomes that fall into the sample space. Given the above definition, between what two numbers must all probabilities lie? So probabilities are based on a scale from 0 to 1. This is a probability scale. That's the probability scale. So from 0 being no chance of it happening, and this being 100%. Percent happening. Right, and right here, this is 50% chance, or 50% chance. Right? So looking at this, right? Given the above definition, between what two numbers must all probabilities lie? Well, that's easy. It's either 100% chance of it happening or no percent chance of it happening. It's somewhere in between, right? You can get 0.5, which is a 50% chance of it happening, but it has to lie between 0 and 1. So between 0 and 1. Okay. So let's look at the back side of this sheet. Then we get to the other forms of probability: theoretical and, like I said, empirical. So just reading the sheet, it says when we deal with theoretical probability, we don't actually have to run the experiment to determine the probability of an event. We simply have to know the number of outcomes in the sample space and the number of outcomes that fall into our event. Let's take a look at a slightly more challenging scenario. Okay, look at exercise 3, the back side of the sheet. Exercise 3 says a fair coin is flipped 3 times, right? So I'm going to actually put that on the screen. So I'm going to get rid of this and do this right here, and I'm going to paste the clipboard. Okay, so we're looking at 3. A fair coin is flipped 3 times, and the result is noted each time. The sample space contains the ordered triplets, heads, heads, tail, such as heads, heads, tail, which would represent a head on the first toss, a head on the second toss, and a tail on the third toss. Draw a tree diagram to show all the different combinations in the sample space. So this is what you're going to do. So we have our first try, right? It's a coin. It's going to be heads or tails. After you have heads or tails, right? Sample space would be at the end where you tally up everything of sample. So heads and tails. Then you get a result of a head. Let me draw in a different color. A head and a tail. Right here, also a head or a tail. A head or a tail. Right? That's one. Oh, come on. 2 and 3 combinations you have, right? So now, this was my first, this was my second. These are my possibilities. Now I'm going to do it again for my third, right? So this time I'm going to have, let me use green. This one right here, this one right here. Heads, tails, heads, tails. Right here again, heads, tails, heads, tails. A sample space would be all these right here. And then we have here. That wasn't particularly wise. Just redrawing this, guys. Sorry. Heads, tails. So if I highlight just my top rows, it's heads, heads, heads. Then I have heads, heads, tails. Then I have tail. Then I have head, tail, heads. Sorry. I have head, tail, heads. I have head, tail, tail. All right. That's in my first 3 tries, right? Then for my second set, I get tails. Let me do it again. Do a different color, pink. Tails, head, head, and tail, heads, tail, and then tail, tail, heads, and tail, tail, tail. Good. Right. Fix this one right here. Okay, that's what we have. That's our sample space. Draw a tree diagram to show all of the different outcomes in the sample space. Okay, list all the outcomes as ordered triplets. How many of them are there? So there are about 8 outcomes. Okay, then for C it says find each of the following probabilities based on your answers from A and B, right? So all heads, the probability of getting all heads, the entire sample space is going to be the event. Yeah, no, sorry. The entire sample space is going to be the sample space from the original formula. Remember, we have the outcomes over the sample space, right? So we want all heads. So there's only one that has all heads. So it's going to be 1 over 8. 1 over 8. Exactly 2 heads. So which one has exactly 2 heads? Well, there's this one right here. Let me see. There's this one right here. That has 2 heads. That has 2 heads. That has 2 heads. Exactly 2 heads, remember. And no other. So that's going to be 3 over 8. All heads or, now it says or all tails. So this is all tails right here. It's all heads. So this was essentially 2 over 8. Right, so everyone clear on that? Exercise 4. I'll read this one, and I'll read the exercise, and then that'll be the first one I continue with tomorrow, or Thursday, or Friday. Right, well. So sometimes we have quantities. Sometimes we have to quantify chance by using observations that have been made in the real world. In this case, we talk about empirical probability. The fundamental equation for probability still stands. A survey was done by a marketing company to determine which of 3 sodas was preferred by people in a blind taste test. The results are shown below. Find the empirical probability that the person selected at random from this group would prefer soda B. Express your answer as a fraction and as a decimal accurate to 2 decimal places. All right, so we have soda. Find the empirical probability that a person selected at random from this group would prefer soda B. So soda B is going to be 24. 24, right? So it's going to be 24. Express your answer as a fraction and to decimal accuracy. So it's going to be 24 over the total amount of people that prefer soda, right? So ABC prefers soda, but some people like soda B. Say soda B was like Pepsi. So it's 24 over 53. Now you could divide that and get a decimal result. B says find the empirical probability that a person selected at random from this group would not prefer soda. Would not prefer soda. Soda A. Not prefer soda A. Alright, so again, express your answer as a fraction and as a decimal accurate to 2 decimal points. So this is for A right here. So we're talking about what is not 18. So essentially just 24 and 11, which is going to give us 35. 35 over 53. So guys, any questions, guys? Any questions? Please let me know, okay? If not, then I have a lot of pressing things. I have a meeting that is about to start, so I will answer any questions you have on the Google Classroom or here. All right? So, thank you guys, and I will see you on Friday. Take care.